Conducting expert judgment elicitations requires having a predefined procedural method, a protocol, that helps standardize the steps involved in such elicitations and facilitates the evaluation of results through peer review. In this video, we will talk about one such protocol for structured expert judgment called the IDEA protocol. Which are the elements that put the structure in structured expert judgment protocols? Well, as in any other scientific process, we first need to make sure that we follow transparent methodological rules. Then, it is important that the questions for the experts have clear operational meanings. These questions should be asked and embedded in the protocol in a way that mitigates psychological and motivational biases. A structured protocol includes the possibility of identifying the experts, that is, participation in the study will be noted, but their judgments and any other input will be recorded anonymously. Allowing for empirical control may sound odd for an expert elicitation which is undertaken when data are lacking or sparse, but this refers to the calibration questions you have learned everything about in the previous videos describing the classical model. Having every step thoroughly documented, it's obviously essential for replication and peer review. A handful of protocols call themselves structured, and even though they differ in several aspects, they all agree that having more than just one expert is absolutely key. The advantage of having multiple experts are the diversity of opinion, the multiple potentially independent sources of information, and the decentralization of ideas, since individuals draw on their own local knowledge. However, multiple experts will produce multiple judgments, which most often need to be aggregated. There are three main ways of aggregating expert judgments that we will very briefly discuss. These are the behavioral aggregation, the mathematical aggregation, and the mixed aggregation. One of the key elements of behavioral aggregation is that it seeks consensus, and it aims to reach it through extensive facilitated discussion between the experts. This discussion stage involves face-to-face interactions and extensive feedback. While well-functioning facilitating groups offer experts the opportunity to share knowledge and correct misunderstandings, such interaction is frequently prone to biases, including polarization of judgments and groupthink. Mathematical aggregation provides an alternative to behavioral aggregation. An explicit mechanistic rule, like a weighted linear combination of judgments, can, for instance, be used. Equal weighting is often preferred because of its simplicity, but differential weighting can be used instead. As you have already learned, the classical model for structured expert judgment uses performance-based weights in the linear aggregation of judgments. Most often, when mathematical aggregation is used, experts are elicited individually, so the interaction between them is restricted, and so is the feedback from facilitators. Mixed aggregation combines behavioral and mathematical aggregation techniques. Maybe the most common mixed method is the Delphi method, where experts receive feedback over successive questionnaire rounds in the form of other group members' judgments. Experts remain anonymous, and they only interact indirectly through a facilitator who provides feedback between rounds. As originally conceived, the Delphi method strives to reach consensus after a small number of rounds. In modern usages of the Delphi method, if consensus is not reached, the final judgments are equally weighted. The protocol that I want to introduce in this video, the IDEA protocol, synthesizes specific elements from all three types of aggregation mentioned earlier. In doing so, it aims to minimize the disadvantages of existing methods and to optimize their advantages. Most elements that characterize IDEA are not new. Its most important contribution is the structured approach to combining these elements. IDEA stands for investigate, discuss, estimate, aggregate. In the IDEA protocol, experts give individual judgments over subsequent rounds, typically 2. Extensive facilitated interaction takes place between rounds. Facilitators provide feedback on the first round of estimates. However, IDEA does not seek consensus and cannot always ensure full anonymity. The last rounds of judgments are mathematically aggregated using equal or differential weights. First, we identify a group of diverse experts. Each expert is asked to investigate the problem and individually give a first round estimate. Once all experts gave their first round estimates, graphs like the one in the middle of this slide are compiled. Experts are then provided with the anonymized judgments of their peers and can endorse agreements and discuss disagreements, allowing people to reconcile the meanings of words and context and share existing evidence supporting the estimates. In a face-to-face discussion, people are often forced to declare their identity, exposing them to dominant individuals and potential pressure to conform. Nevertheless, people may refrain from defending their estimates to avoid identification. Post-discussion, experts are invited to consider and balance all arguments and give a second round of individual and anonymous estimates. This may or may not differ from their first round of estimates. Experts' estimates obtained through the second round are mathematically aggregated. The method for mathematical aggregation is not dictated by the IDEA protocol. Instead, it can be chosen by the analyst. The classical model for aggregating expert judgments is one such choice. Assume that we are now incorporating the classical model into the IDEA framework. The classical model typically asks for 3 quantiles of a distribution for each variable of interest: the median, an upper, and a lower quantile. One detail that is important when the IDEA protocol is used refers to the order in which the quantiles are asked about. We insist that the lower and upper quantiles are elicited prior to the median to avoid anchoring on the central estimate and the overconfidence that comes with this bias. These individual biases were discussed in the heuristic and biases video that you most probably already watched. Because the IDEA protocol involves both individual and group work, the number and nature of biases changes accordingly. In addition to the individual biases, group biases like groupthink, dominance, polarization of judgments need to also be mitigated against. Several strategies implemented in the IDEA protocol try to mitigate against biases. The first individual estimate avoids anchoring on others' estimates. The extensive discussion reduces the effects of the availability bias. The second individual anonymous estimate reduces dominating effects and groupthink, and the question format reduces anchoring and overconfidence, as already mentioned. You will have the opportunity to see the IDEA at work after this video. Thank you for your attention.